This is the 7-5 notes, factoring polynomials. Your objective is that you can factor polynomials. Alright, so today we're going to be factoring some of the polynomials. Option 1, we have a couple different options available to us. As been our thing lately, you guys kind of have possibilities and choices on what you get to make. Sometimes one method works better than the other. Sometimes you might just favor one over the other. I know I personally do, but that's up to you. So the first option that we have is guess and check. And as you can probably imagine, this involves, well, guessing and checking and seeing if something works out. So, number 1, we have x squared plus 5x plus 6. And so what we're looking for is we're looking to factor this. And what I mean by factor is it needs to be set up in a set of parentheses like this. And there's going to be some kind of order or arrangement to it that makes this work. Now the way that I approach this, I always start off by factoring this last number. If you can imagine that there's an A, a B, and a C, I'm going to factor my C method. So I'm going to do factors of 6. What are factors of 6? Factors of 6 are 1 and 6, 2 and 3, and that's actually all of them. And I say, okay, cool. I got factors of 6. I do factors of A, or factors of C. I do factors of A, which are just 1 and 1. The A ones are actually pretty powerful in the fact that because it's just 1, I know that both of these are x. Now the question is, what else goes with them? And so what we do is we take factors of C and we see, okay, which ones add up to make positive 5, or that B. And so when I look through these, I go, hey, 2 and 3 do. And I get a plus 2 and a plus 3. And what you can do, and the reason that people call this guessing and checking, is you actually could really start with, all right, does x plus 1 work with x plus 6? Or does x minus 1 work with x plus 6? And there's kind of like all of these different options that you can try, and you can go through and you can kind of, nope, this one doesn't work, this one doesn't work, this one doesn't work, this one does. So, yeah. So my factor, so factoring this, we have this. So our answer is x plus 2, x plus 3. This isn't set equal to anything, so you don't go any farther. If this was set to equal to 0, then we would go. But because there's nothing else with this, we're just going to leave it as is. Alright, number 2. I have x squared plus 8x plus 12. I guess we can do this kind of that true factoring style, guess and check style. So I kind of go through and I say, okay, what are factors of 12? So I have x and 1, x and 12, x and 2, x and 6, x and 3, x and 4. And so as we go through this, I kind of say, all right, it needs to be positive, so all the signs are the same. And this needs to be positive 8, so all of these have to be pluses, which helps reduce, eliminate some of our possible answer choices. So as I go through, I go, okay, 1 plus 12 is 13. 2 plus 6 is 8. Hey, that one's promising. X minus plus 3 plus 4 is 7, so that one doesn't work. So neither of these work. That leaves me with x plus 2, x plus 6. Again, because it's not equal to anything, we don't go any farther. Number 3, we have z squared plus 11z plus 28. Again, I'm going to go and do factors of 28. 1 and 28. I actually really did that on 2, but I didn't write it out. I'm going to go through factors of 28. So 1 and 28, 2 and what is that? 14. 4, and 7. I think that's all of them. And so you can definitely help yourself out a lot and kind of look at things that are going to work with that middle, with that B number. And everything needs to be in standard form, by the way. And so working through this, I say, okay, I know there's going to be an X and a 4, an X and a 7. That's pretty much the only thing that works, because if I add or subtract this, I get 27 or 29, 16 or 12, 11 or 3. And so I know that my middle number is 11. So looking at this sign with the 28 tells me that they're both going to be the same, and the 11 is positive, so I put a plus with both of them. All right, what's left is the other option that you have available to you is option 2. So option 2 is the box method backwards. And it's kind of as it sounds. We're doing the box method backwards. So for number 4, we have w squared minus 7w plus 12. Now, if you remember the box method from like 2 lessons ago, I think, we kind of separate it out into a box like this. What we do is we can label these A, B, and C. Your A is going to go in the upper left, and so this is a 1, so I have 1w squared. Our C goes in the bottom right, so it's 12. And our B is going to get split between these two. And so I know that I'm going to have a W and a W. And so what I do here is I do factors of 12. So 1 and 12, 2 and 6, 3 and 4. And I need to figure out, and I kind of set this up. So you can kind of imagine this of what times what and what plus what. So what times what equals 12, and what plus what equals negative 7. So when I look through these, the only ones that get me to 7 are 3 and 4. Alright, so 3 and 4 is 12, but 3 plus 4 is positive 7. So if I make both of these negative, negative 3 times negative 4 is still positive 12, and negative 3 plus negative 4 is negative 7. So this is negative 3, and this is negative 4. It doesn't actually matter the order. You could do it either way. And now what we're looking for is what each line has in common. So looking at this row, I see negative 3w and 12. Those have just the numbers. They only have numbers in them. So that tells me that this is going to be a number, and specifically I get to use that negative 3. If I look at that top row, I see that they both have 1. 1 doesn't really mean anything though. So w squared and negative 4w, they both have a w in common, so there's going to be a w there. Look at the first column. They both have w in common, so there's going to be a w. And then in the second column, I have negative 4w and 12. Those both have a number, specifically negative 4. So my answer is w minus 3, w minus 4. Alright, number 5. I have y squared minus 14y plus 24. Okay. This is my A, this is my B, this is my C. I know I'm going to need factors of 24, so 1 and 24, 2 and 12, 3 and 8, 4 and 6. So as I go through these, I'm going to need something times something equals 24, and those same things need to add together, and I get the add from that, need to add together to make negative 14. So as I'm going through, 1 and 24 don't add up to get near 14 at all. 2 and 12 do. So those are very likely. See if anything else does. 3 and 8, 4 and 6. 3 and 8 does 11. 4 and 6 does 10. Doesn't work. So I know I'm going to have 2 and 12. These both need to be negative so that I can make negative 14. And negative 2 times negative 12 is positive. Alright, so I have the y squared, I have the 24, I have the y, I have the y. So that leaves me with negative 2, negative 12. Those are y's because they both have those. That's kind of how that one always works out. Along the bottom here, they have negative 12 in common. Along the top, they have negative 2 in common. So I have y minus 2 and y minus 12. Now for number 6. Number 6, x squared minus 11x plus 28. So in doing the box method, go ahead and start kind of taking some of those quick steps. So I know this is going to be x squared. I know this needs to be 28. I know that both of these are going to have an x with them. I know that this and this both are going to have the x because they have those x's in common. So what I need to do is I need to find factors of 28. And specifically what I'm looking for is I'm looking for them to add up to make negative 11. So in adding these up, I go, okay, factors of 28. What factors of 28 are 1 and 28, 2 and 14, 4 and 7. So I need these to subtract to make negative 11. So looking through, this makes 29, this makes 16, this makes 11. So I need a 4 and I need a 7, but I need them to both be negative. So I need this to be negative 4 and this to be negative 7. So this winds up being negative 7 and this one winds up being negative 4. So I get x minus 7 and x minus 4. All right. Number 7, we're going to be doing, you get to choose your own method. So in doing that, we have x squared plus x minus 20. I'll do kind of the guess and check, and then I'll kind of switch back and forth. So as I go through this, I go, all right, I'm going to have an ordered set like that, or just a parentheses. The a out front is 1, so that means this is going to be an x and an x. I need factors of 20. So I need 1 and 20, 2 and 10, 4 and 5. And I'm specifically looking for which ones make 1 whenever they subtracted. And so I have a 4 and a 5. Then whenever I get to this, I say, okay, which one do I need? I need it to, my middle number to be positive. So I'm going to kind of make my bigger number positive. And that works. Number 8, y squared minus 6y minus 16. So going through this, I'm going to use the box method on this one. So this is negative 16, this is y squared, this is y, this is y, this has a y, this has a y. Okay, so factors of 16, my factors of 16 are 1 and 16, 2 and 8, 4 and 4. Specifically, I need them to subtract to make 6. and even more specifically -6. So looking through these, subtracting, I get 15, I get 0. Hey, this one gives me 6 if I go 2 minus 8. And so my 8 is negative, and my 2 is positive. So I get y plus 2, y minus 8. Number 9, I have m squared plus 8m minus 9. I'll do the kind of guess and check method. So I say, okay, what are factors of 9? Factors of 9 are 1 and 9, 3 and 3. This says that I need to have a difference. So there's an m, there's an m. I know one's going to be positive, one's going to be negative. That's the only way to make this happen. And I'm going to need to plug them in so that it makes a positive 8. So I'm going to put 9 at the front and 1 at the back, because 9 minus 1 is 8. Number 10. Number 10 says a projector displays a rectangular image on a wall. The height of the wall is x feet. The area in square feet of the projection is represented by an equation, specifically x squared minus 12x plus 32. We do know that the width of the projector is x minus 4. This is the width. So A asks us to write a binomial expression that represents the height of the projection. So what I'm going to do is I'm going to utilize the tools that were kind of already given to us. A rectangle, I know, is the length times the width. And I already have the width. I have that the width is x plus 4. I don't know why I decided to write that twice. So my length is x minus 4. So I know specifically that I need to use this x minus 4 in this. And so I'm kind of going a little bit backwards. But what I'm actually going to do to kind of help me out with this, I'm going to go, okay, what are factors of 32? Factors of 32 are 1 and 32, 2 and 16, 4 and 8, and then I think it just wraps back around at that point. Yeah, it does. Okay. And so I say, all right, wait, this one, I already have a 4, now I need the 8. And so what I'm going to put into this is x. It needs to be the same sign, that's what this plus tells me. And I got negative 12, or negative 8. Now, if you wanted to use the box method for this, you totally could, and it actually might be a little bit easier for you. In that you know that we have x and a negative 4, and you also know that this needs to be x. And so we have x squared, we have negative 4x. I need these combined to make 12, and so I need this to be negative 8. And then you just go, okay, this is negative 8 times, and that's 32. And I guess you could fill that in before. You would have had just about everything there. Alright, part B asks us to find the perimeter of the projection when the height of the wall is 10 feet. So doing this, I really would recommend kind of sketching it out. So the height of the wall is 10. And we know that the equation for that is x minus 8. And that's actually really just equal to it. So 10 equals x minus 8. And this is x minus 4. So if we know that x minus 8 equals 10, equals 10, I want to solve for x, so I add 8 to both sides, so I get x equals 18. But this side still stays at 10 feet, and so this side is also at 10 feet. What we use this x for is we use that to calculate how wide it is. And so I say, okay, x minus 4 equals unknown, instead of x, I'm going to write 18 minus 4, and 18 minus 4 is 14, so my width is 14. I add these up, 10 and 10 make 20, 14 and 14 make 28, 28 plus 20 is 48, so 48 feet squared, or not squared, because we're doing a perimeter. Okay. Number 11. Describe and correct the error in factoring the polynomial. So they have x squared minus 11x plus 18 equals x minus 3, x minus 6. So kind of the easy way to check and see kind of maybe what they did wrong is you can just use FOIL. Using this, I'd say, okay, I got x squared minus 9x plus 18. Oh, they got their b's wrong. So in fixing this, so I'd go, okay, what are my factors of 18? 1 and 18, 2 and 9, 3 and 6. Do any of those combine to make 11? Yeah, 2 and 9 do. So this should be x minus 2, x minus 9. So let's start doing number 12. Number 12 gives us area of a rectangle is 45 square feet. And we're given a rectangle, looks like that. And we're told that this is x minus 14, and this is x minus 2 feet. And so what we need to do is we need to figure out, okay, what's our value for x so that we can find the dimensions of this polygon. So the way we set this up is we go, okay, x minus 14, x minus 2, we set that equal to 45. And we're going to go ahead and distribute this and kind of get it built out, and then we're kind of going to work backwards. It's going to be kind of interesting. So we go x times x is x squared. X times negative 2 is negative 2x. Negative 14, I'm doing FOIL method here. Negative 14 times x is negative 14x. And negative 14 times negative 2 is positive 28. That equals 45. Combine like terms, we get x squared minus 16 plus 28, 16x plus 28 equals 45. I'm going to subtract 45 from both sides, and it doesn't impact this x squared minus 16x. What it does change is it changes this 28 to negative 17. Now we can go ahead and we can try and find factors so that then we can use that the zero product property. So I guess since I'm just doing it this way anyway, working backwards, I got x and x. I need factors of 17, so 1 and 17 because that's a prime number. So I have 1 and I have 17. The minus tells me that 1's going to be negative and 1's going to be positive. And this negative 16 tells me that the 17 is negative and the 1 is positive. That equals 0. I solve for x, so I get x equals negative 1 and 17. Now, whenever we're talking about a distance, is it possible to have a negative distance? No, it isn't, so I don't use that one, so my answer is going to be 17. But that's not quite my full answer. That's the answer for my x value. So if I plug that in to my rectangle, I get that the height is 17 minus 14, or 3. And this is 17. I'll just say those as 1. (17) minus 2, which is 15. So I have 15, 15, 3, 3, 15, 15 make 30, 3 and 3 make 6, 30 plus 3, 6 is 36. So I have a perimeter of 36 feet. All right, let's make number 13. So for number 13, we have the area. It's 35 centimeters squared. And we have a triangle where this is x minus 14 centimeters, and this is x minus 5 centimeters. So given that, we're actually going to use the idea that a triangle is 1/2 the base times the height, and that's going to give us 35. And that leaves us with 1/2. Our base is x minus 5, and our height is x minus 14, and that equals 35. Now, I could keep this 1/2 over here, however it's going to kind of mess things up. So what I'm going to do is I'm going to multiply both sides by 2, and that's going to make it so that I can kind of solve this a little easier. It just kind of looks a little more familiar. X minus 14 equals 70. So I go x squared, negative 5x, negative 14x makes negative 19x. Negative 5 times 14 is positive 70. Yeah, which equals 70. I subtract 70 from both sides. So I'm left with x squared minus 19x equals 0. I factor this out, so I take out an x. That leaves me with x minus 19 equals 0. So my x's are 0 and 19. Now, obviously, 0 makes no sense because if I plug that in, I'm going to get a negative distance. That doesn't work, so it's going to be 19. So my x's, so my height, my x minus 14, which is my height, if I plug in 19, I get 5 is the height, and x minus 5 is my base. So my base equals 14. Number 14 asks us to write an equation of the form x squared plus bx plus c equals 0 that has the solutions x equals negative 3 and x equals 8. So we're kind of working backwards. This is number 14. We're working backwards. We're starting with our answers. So x equals negative 3 and x equals 8. And this is a spot where potentially that the box method is really handy. In that we go, okay, well, we know what our answers are already. We have negative 3, we have 8. We know that these are both x's. And so now we just do this type of stuff. So we get x squared, we get negative 3x, we get 8x, and we get negative 24. We go x squared. Negative 3 plus 8 is positive 5x. Negative 3 times 8 is negative 24. And that's it. And that's kind of how we found our answers. We used that box method. All right, that's everything. Have a good one. Or check with your teacher on what assignments you have. And have a good one.